All right, hi everybody. So the first thing that we're going to talk about is functions. All right, and notice that there are 4 different types of graph here. We have one that looks like a straight horizontal line, one that looks like a straight diagonal line, one that looks like a V, and one that is this U shape. Okay, so these are the 4 main functions that we're going to talk about in the first chapter. Whenever you see a horizontal line like this one is called a constant. So this is a constant function. All right, it's a constant function, and the equation for this one is f of x equals some number. So what number are we going to put? Notice that it's on the 1 of the y-axis, right? So it's all the way up here on the 1 on the y-axis. So that means it's going to be f of x equals 1. All right. Now another way of writing this is y equals 1. Okay, this is what I prefer. This is how I prefer to write it as y equals 1. This just lets us know that when x is 0, y is 1. When x is 1, y is 1. When x is 2, y is 1. Y is always equal to 1. That's what that says. Okay. But just remember f of x is the same as y. Okay. So that's our first one. And let's see. Let's look at what f of x equals negative 2 looks like. So f of x equals negative 2 is going to be at negative 2 on the y-axis. So we have 1, 2, negative 2. Ta-da! And we're just going to draw a straight horizontal line. All right. And there we go. And you'll usually see the equation right next to the graph, just to let you know what the function was. So f of x equals negative 2. Now, how do you know that? If you're not sure, you can always make a table. Okay, if you're not sure how to graph something, make a table. All right, make a xy table. I'm going to do mine horizontally since I didn't leave too much space. All right, and we could do like 5 points if you want. That's good. And which points are we going to choose? Let's choose a negative 4. Let's choose negative 2. Let's choose 0. Let's choose 1. And let's choose 3. Okay, I'm just choosing random points there. So how we do this is we want to substitute these x values into this equation. Now, if we do that, again, just remember f of x is the same as y. If we do that, we're going to plug in negative 4 into x. So we have f of negative 4 equals, is there anywhere to put the negative 4 on the right side? Nope. So it just stays negative 2. Negative 2. And let's try it again. F of negative 2 this time, because that's our x, equals, ta-da, negative 2. And same over here. F of 0, because that's our x, equals, anywhere to put the 0 there? Nope. So still negative 2. You see how it doesn't change? So this is going to be negative 2, this is going to be negative 2. It's just going to be negative 2, negative 4 comma 0, negative 2 comma 0, sorry, negative 2 comma negative 2, 0 comma negative 2, 1 comma negative 2, and 3 comma negative 2. Okay, so that's how you can graph a function, especially a constant function. So let's do the same thing for f of x equals 3. We have, just count to 3 on the y-axis, 1, 2, 3. And then draw a horizontal line, and that's it. Okay, and if you want, oops, missed it. There we go. Now if you want to make that a table, just like we did over here. Same thing. All right, you'll always end up with 3's there. And you can fast forward through this if you got that part. So -4, -2, I'll keep them the same. 2 and 4 there. So this one's 3, 3, 3, 3, 3, because it's never going to change. All right, that's a constant. Now, this one I left blank. The reason why is because I was going to ask, what number do you think we're going to put to get that x-axis, this x-axis? To get a line on the x-axis, what number is that? This is 1, this is -1, so in between 1 and -1 is, ta-da, 0. Okay, so f of x equals 0 is the x-axis, in case you're wondering. So that's a constant. Now let's look at this one. If you have a diagonal line, this is called a linear function. This is a linear function. And the function for this one is f of x equals x. All right. Oh, I forgot to mention, these are the parent functions for these functions. Okay, so the parent functions is just talking about the basic function, the basic equation for those functions. Okay, so let's say we had f of x equals x plus 3. So if we're adding 3 to this x, what would it look like? Okay, and again, if you want to change this to a y, it makes it better for me. I don't know if it helps you. But I know you've seen that before in Algebra 1. Y equals x plus 3, you can find the slope, find the y-intercept, and then graph it like that. Yeah, again, if you're not sure, make a table. It's easy. All right, xy table. There we go. Stick with 5 points. You could do less if you want. All right, and I only have -4, -2, 0, 2, and 4 again. Let's do that. -4, -2, 0, 2, and 4. All right. So if we plug those in, watch this one. This one changes. We have f of -4, or again, this is still y, so y equals, and instead of x, we're going to plug in -4, -4 plus 3. So -4 plus 3 is going to give us -1. Okay, so we're going to put at I'll do that later. And then at -2, when x is -2, we're going to have f of -2 equals -2 plus 3 is 1. Oops, we got to put -1 here. This is 1. All right, and then you can just repeat that. Oh, sorry, I didn't leave a lot of space. I'll put it over here. F of 0 equals, instead of x, we're going to put 0, right? Because that's our x plus 3 is 3. And f of 2, and hopefully you're noticing that it just goes up by 2 each time. All right, so f of 2 equals, and then 2 plus 3. 2 plus 3 is 5. All right, so it's going up by 2 each time, so this is going to be 7. You can try it out. 4 plus 3 is 7. Okay? And let's plot those points. -4, -4, comma, -1. It's down here. -4, -1, -2, +1, 0, comma 3, 0, up 3, 3, and 2, comma 5. Go to the right 2, up 5. Oh, there is no 5, so I'm going to put it up here where it would be. And we connect those dots, those points. Hey, look at that. Notice that it looks parallel. Remember that from geometry. All right, intercepts or the slopes are the same, and they're never going to intersect. And yeah, that's it. So these were parallel over here, and these two are parallel as well. Okay, let's look at what x minus 3 looks like. And if you notice this, x plus 3 goes up 3 spaces. So here we have 0. So 1, 2, 3. Each point is moved up 3 spaces. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, 1, 2, 3. Well, the points are moved up 3 spaces. Now, if you have x minus 3, guess what happens? It's going to be moved down 3 spaces. All right, so you can move each space down, each point down 3 spaces. 1, 2, 3. Put a point. Okay. And here we have another one. 1, 2, 3. Here's another point. 1, 2, 3. Another one. 1, 2. We're going to run into the equations there, so let's not do that. Over here we have 1, 2, 3. And again, you can make a table just like we did over here. Same thing. It'll give you the same. All right, so we're just moving everything down 3 spaces. And 1, 2, 3, etc., etc., etc. Ta-da! It's parallel again. Yay! All right, this is f of x equals x plus minus 3. This is f of x equals x plus 3. I think I went out of the shot there. Sorry. But there we go. Now, what if I wanted a line that went this way? It went, instead of going up from left to right, it went down from left to right. So that one, it would be, let's see if you remember from Algebra 1, negative x. Okay, so instead of f of x equals x, it's f of x equals negative x. Now, how do you know? Table time. All right. So you have negative 4, negative 2, negatives, 0, 2, and 4. All right, plug in negative 4. So you have f of negative 4 equals negative 4. Negative 4 is positive 4. Ta-da! And if you put negative 2, negative 2 would be positive 2. Negative 0 is just 0, and negative 2 is negative 2. Negative 4 is just negative 4. All right, so let's see what that looks like. Negative 4, comma 4, go to the left 4, up 4, there we go. And negative 2, go to the left 2, up 2, sorry about that. And 0, comma 0, go to the 2, comma negative 2, go to the right 2, down 2, and 4, comma negative 4, go to the right 4, down 4. Ta-da! Look at that. And I'll show you guys how to graph these on Desmos later. Okay. So that is that. Now, you're probably wondering, oh, so constant and linear. Constant is a horizontal line, linear, a diagonal line. Now here we have this V shape. Okay, let's see if you remember what this is called, what kind of function this is, but I'm sure you saw this in Algebra 1. This is an absolute value function. Absolute value function. All right, and a way to remember this is absolute value, V. The graph is a V. Value, absolute value. And what this looks like is f of x or y equals absolute values, those two lines, x Okay, or you can say y equals absolute value of x. Whichever one you prefer. Now, what does f of x equals absolute value of x minus 2 look like? So we have absolute value of x minus 2. I don't know. Let's graph it. All right. And remember, absolute values, it's the distance, how far the number is from 0. So basically it's, and you can't have a negative distance. So it's changing all negative numbers to positive numbers, basically. And if it's positive, it stays positive. So let's use -4, -2, 0, 2, and 4 again. All right. So let's plug in -4 here. You get f of -4 equals absolute value of -4 minus 2. So the absolute value of -4 makes it positive 4. Makes any negative positive. So 4 minus 2 is just 2. Ta-da! And same thing over here. -2. Okay, absolute value of -2 is positive 2. So 2 minus 2 is 0. And same thing with 0. 0, absolute value of 0 is just 0. 0 minus 2 is -2. All right. And then if we plug in 2 this time, I'm going to show this one. A lot of students, they make a mistake by changing it to a negative. Remember, absolute value always makes it positive. So f of 2 equals absolute value of 2 minus 2. Absolute value of 2 is 2 minus 2 equals 0. There we go. And absolute value of 4 is 4 minus 2 is 2. All right, so let's look at what that looks like. -4 comma 2, go to the left 4, up 2. -2 comma 0, go to the left 2, up 0. Just right there. 0 comma -2, so just go down 2. 2 comma 0, go to the right 2, and just stay there. And then 4 comma 2, go to the right 4, up 2. And connect the points. Ta-da! Makes a V. Pretty cool. Now, if you're wondering, what about if you're adding or subtracting on the inside? This is a little different. I'm going to show you with the table what happens, okay? So watch this. Oops. Watch what happens with the table. It's pretty cool. -4, -2, 0, 2, and 4. All right. So we have f of -4 is absolute value of -4 minus 2. So here we have to do the inside first. So -4 minus 2 is going to give us -6. So absolute value of -6 is 6. Ta-da! All right, so let's try the next one. -2. So -2 minus 2 is -4. Absolute value of -4 is +4. And then let's try 0. 0 minus 2 is -2. Absolute value of -2 is 2. Let's try 2 this time. All right. 2 minus 2 is 0. Right, I don't know if you want me to show that. Let's do it. F of 2 plus 2 minus 2, which is 0. Absolute value of 0 is just 0. Ta-da! And then 4. 4 minus 2 is 2. Absolute value of 2 is 2. Alright, so let's plot those. -4 comma 6, don't have enough space. -2 comma 4, go to the left 2, up 4, right there. 0 comma 2, go to the up 2, 1, 2. 2 comma 0, go to the right 2, and it stays there. And then 4 comma 2, go to the right 4, up to, da-dun. Watch this, this is pretty cool. Da-da-da-da-da-da-da-dun. All right. So what it does is when you're adding or subtracting on the inside of the absolute value, it's actually moving it to the right. You see that? Moves everything to the right 2. 1, 2, 1, 2, 1, 2. So if you're subtracting, you're going to move it to the right 2. So if you're adding 2, hopefully you got this, what you're going to be doing is you're going to move everything to the left 2. 1, 2, point. All right, here's a point. 1, 2, point. And here's another one. All right. Here's a point. 1, 2. Da-da. Here's a point. 1, 2. Another one. 1, 2. And 1, 2. And I hope you got the idea. There we go. Because that's pretty cool when you put them all together, right? So if you're adding or subtracting on the outside, it moves it up or down. Up or down. It's called a translation, a vertical translation, down 2 units. We'll talk about that later. And if you're adding or subtracting on the inside, you're going to move it to the right or to the left. You're going to move it to the right if it's a minus, and left if it's plus. Okay, and I'll talk about that later. Now, why did I put this? Reflection. So if we want to reflect this across the x-axis, right, we want to make it, instead of a v, we want to make it an upside down v. You want to put the negative on the outside. Just like that. All right. And you can make a table to check if you don't believe me. Alright, so f of negative 4 equals negative absolute value of negative 4. So absolute value of negative 4 is 4. And then that negative is still there, so because it's not on the inside, right? So it's still negative 4. Here, negative 2, absolute value of negative 2 is going to give us, absolute value of negative 2 is 2, and we still have that negative on the outside, so it's still negative 2. And 0 to negative 0, but there's no negative 0. And 2, absolute value of 2 is 2, but you have a negative there, so it's a negative 2 as well. And absolute value of 4 is 4, and you have the negative on the outside, so negative 4. Ta-da! So negative 4, comma negative 4, negative 2, comma negative 2, 0, comma 0, 2, comma negative 2, 4, comma negative 4. And there we go. That's our graph. That's called the reflection. And I'll show a better one on Desmos. Okay, so don't worry about that. And I noticed that I didn't get on the screen. There you go. Sorry. All right, let's look at the last one. This one, hopefully you remember from Algebra 1 and Geometry. This is a parabola, and this is a quadratic function. It's a quadratic function, and what does it look like? It's f of x equals x squared. All right, so what if we're adding or subtracting to the x squared? Let's say we're subtracting 4. So let's make a table. Table time. Negative 4, negative 2, 0, 2, 4. All right, so we have f of negative 4 equals equals negative 4 squared. I'm going to put that in parentheses because it's negative, minus 4. So negative 4 squared is 16, positive 16, minus 4 is going to give us 12. And I'm not going to have enough space for that. So that's 12. Let's try negative 2. We have negative 2 squared minus 4. All right, negative 2 squared is 4. Minus 4 is 0. All right, and let's plug in 0 this time. So 0 squared is 0. Minus 4 is negative 4. 2 squared is 4. Minus 4 is 0 again. And 4 squared is 16. Minus 4 is 12 again. Hey. All right. Oops, sorry about that. So let's plot those points. Negative 4, comma 12, all the way up there somewhere. Negative 2, comma 0. I'm going to put that right here. 0, comma negative 4. 2, comma 0. And 4, comma 12. Yeah, so this one looks like this. Okay. So it's actually just like that parabola. Looks skinnier, but it's actually the same. It's just moved down, just like before the absolute value. Adding or subtracting it moves it up or down. Same with this one. If you add or subtract a number on the outside, you're going to move it down. Okay. If you add, you're going to move it up. If you subtract, it's going to be translation down. All right. Now here we have f of x equals x minus 1 and all that squared. Okay, just like how here we were subtracting on the inside of the absolute value, here we're subtracting on the inside of the square. So let's try it. Table time, x, y, and get negative 4, negative 2, 0, 2, and 4. So let's try it. F of negative 4 equals negative 4 minus 1 squared. So we're going to do negative 4 minus 1 is negative 5. Negative 5 squared is 25. All right, and same thing, negative 2 squared. So negative 2 minus 1 is negative 3. So you get negative 3 squared is 9. All right, don't have enough space for that one either. 0 minus 1 is negative 1 squared. Negative 1 squared is 1. And here, 2 minus 1 is 1 squared. It's going to give us 1. And then 4 minus 1 is 3 squared is 9. Uh-oh. So what that looks like is 0, comma 1, 2, comma 1, and actually we have a 1, comma 0 right here. All right. And we'll go into more detail for these quadratics in the next section, next chapter. There you go. This one is shifted to the left as well. It's a translation, a horizontal translation to the right. And x plus 1 squared was going to give us a horizontal translation to the left. Right, and I'll show you on Desmos for that one. Okay. Oh, and if you want to get the reflection across the x-axis, you want to make it upside down basically. You want to make this a negative x squared. Make sure there's no parentheses for this one. The negative should be on the outside of the parentheses. Okay, just like the negative is on the outside of the absolute value, the negative should be on the outside of the parentheses, and that's going to give you this. Okay, it's going to give you -1 comma a -1. It's going to give you -2 comma -4, 0 comma 0, 1 comma -1, and 2 comma -4. Well, looks like a cute little puppy. There you go. And that's it. Looks like a mess. I'll show you again on desmos.com. Just remember, if it's a horizontal line, constant function, diagonal line, linear function, v, absolute value, and a parabola, quadratic.